It's time for Maths with Mr. Thomas.
Heidi ho, let's go! Chapter 8, lesson number 2, sketching rational functions. Woo! So first of all, what is a rational function? Hazel, help us out. Perfect. A rational function is a function that is of the form p of x over q of x, where both p of x and q of x are polynomials. Let's take a basic rational function such as y equals 1 over x. If I asked you to graph that, you will end up with, ta-da! You will end up with this. You can see here as x gets bigger and bigger and bigger, well, the graph is going to get closer and closer and closer to the x-axis. You can see here as y gets bigger and bigger and bigger and bigger, again the graph's going to get closer and closer and closer to the y-axis. It's the same over here as well. As x goes towards negative infinity, well, the graph again is going to get closer and closer to it. And here, when y goes towards negative infinity, again the graph is going to get closer and closer and closer to it. You can see that here with this table of values. If you pick a really, really large value of x, we can see here the y value is going to be very, very close to 0. So the graph will almost be on the x-axis, but not quite. It is not quite going to get there. What that does is it makes the x-axis and the y-axis in this example very special. Because you can see as x gets bigger and bigger and bigger, the graph is getting closer to it. It's the same with y. As y goes off towards infinity, then the graph is getting closer to it. And it's the same here. As x goes towards negative infinity, the graph gets closer and closer and closer. And as y goes towards negative infinity, the graph again gets closer and closer and closer to it, but it doesn't quite touch it. There is a special name for lines that happens to. So lines that the graph approaches but doesn't quite touch as it goes off towards infinity are known as asymptotes. So an asymptote is a line that the graph approaches as either the x or the y coordinates head towards infinity. We note as well, you can see here that when x equals 0, so in other words this y-axis, well, the graph does not exist. So you can see the graph jumps. First of all, it's heading down here away off to negative infinity, and then suddenly it's away up here, so it's jumping over this y-axis. There is no points that are on the y-axis. It is therefore said to be discontinued there. What you can say then is the graph here is discontinuous. In other words, you cannot draw it without taking your pencil off the paper. If you could, then it would be known as a continuous function. So to graph rational functions, what you need to think about are these different parts. You need to consider where the graph crosses the x-axis, and what's the y value when it crosses the x-axis? 0! Brilliant! So it's going to cross the x-axis when y is 0. You need to think about where it crosses the y-axis, and it crosses the y-axis when x is 0. Perfect! So you can do that. You've been doing that for years. What you also need to consider now, though, are the asymptotes. So you need to think about the vertical asymptotes, and these occur when the denominator equals 0. So in your function, take the denominator, set that equal to 0, and that will show you where the vertical asymptotes occur. What you then need to do, though, is you need to think about what happens either side of that vertical line, that vertical asymptote. Really, the graph is going to either approach positive infinity or negative infinity. And you have to investigate the behaviour of the graph, which we'll do in a few examples. As well as vertical asymptotes, you need to think about non-vertical asymptotes. They're not horizontal asymptotes. They don't always need to be horizontal. So, non-vertical asymptotes, these occur when x approaches positive or negative infinity. So you need to consider what's happening as x is either going to be really big or really, really small towards negative infinity. And again, you need to investigate that. And the last thing you may need if you're graphing your function is everybody's favourite, stationary points. If you're asked for the stationary points and their nature, then you need to work that out. So let's start off then with example 1. Sketch the graph of y equals 1 over x plus 2, bracket x take away 3. And we don't need to find the stationary points. Woohoo! So, to start off with, let's think about where the graph crosses the y-axis. We know it's going to cross the y-axis when x equals 0, so let's replace x with 0. Therefore, we would have y equals 1 over 0 plus 2 is going to be 2. 0 take away 3 is negative 3. Multiply them, you get negative 6. So you have 1 over negative 6, or negative 1/6. Therefore, you can say then the graph is crossing the y-axis at 0, negative 1/6. We need to think as well about where it crosses the x-axis. And it crosses the x-axis when, you got it, when y equals 0. So when y equals 0, you will have all of this, the 1 over x plus 2 bracket x take away 3 equals 0. How do you solve that? Good. Multiply both sides by x plus 2 bracket x take away 3. Or you can think about moving that over and multiplying. In other words, you would get 1 equals 0. Say what? That doesn't make sense. That doesn't make sense, so you have to say what it means. Obviously, 1 does not equal 0. So what does that mean in terms of the graph about it crossing the x-axis? Perfect. It means it does not cross the x-axis. If you get something that doesn't make sense, it means it doesn't cut it. So we have dealt with where it crosses the x-axis, where it crosses the y-axis. We now need to deal with the vertical asymptotes. Where do these occur, David? Perfect, when the denominator equals 0. So take your denominator, the x plus 2 bracket x take away 3, and set that equal to 0. If you solve that, you will get two values of x. We get x is negative 2 and x equals 3. Therefore, you can say there are vertical asymptotes when x equals negative 2 and x equals 3. So you're going to get your vertical lines drawn in. What we need to do though is we need to think about the graph, because the graph is going to either approach positive infinity or it's going to approach negative infinity. Again, on the other side of this asymptote is either going to come from positive infinity or from negative infinity. And the way you work that out is you take a value just before and just after the vertical asymptotes. So here, because we've got a vertical asymptote at negative 2, we want to pick a value just to the left of negative 2. So just a bit smaller, always just go out by 1 decimal place. So here I've got negative 2.1. What I'd do is I would feed that into the original equation. And all I'm interested in is, do I get a positive value or a negative value? If I get a positive value, then it means the graph will be approaching positive infinity. If I end up with a negative value, it means the graph will be approaching negative infinity, so it'll be coming down like that. So if you put down negative 2.1, you end up getting positive value, so it's going towards positive infinity. If you end up putting in negative 1.9, so just go to the right of that asymptote, if you put that into the original equation, you end up with a negative, so you know the graph is going towards negative infinity. With the other asymptotes, so let's say at 3, do the same thing again. Pick a value just less than that. Go out by 1 decimal place, so 2.9. If you put 2.9 in here, a lot of the time you can do this in your head, you just want to see if you get a positive or a negative value. If you put in 2.9, you will end up with a negative value, which means the graph is approaching negative infinity. So if you have that asymptote just before it, the graph will be going down the way towards negative infinity. On the other side is a graph coming from positive or negative infinity. We'll pick a value just bigger than the value. So you got 3 for the asymptote, so pick one just before, or just above that, 3.1. If you put that in, you will get a positive value, which means then the graph is coming from positive infinity. So it'll look something like that. After that, so we've dealt with the vertical asymptotes, what we then do is we need to look at the non-vertical asymptotes. How do you think about them? Well, what you do is you consider what happens to y as x tends towards infinity, positive or negative infinity. Really, that's what we started off with then, y equals 1 over x plus 2x take away 3. And really, as x gets bigger and bigger and bigger and bigger, well really because you have a fraction and you would be dividing it by a bigger and bigger and bigger and bigger and bigger and bigger number, then it means it's going to get very, 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 very close to 0. So in other words, y is going to approach 0, or y will tend towards 0. So as x tends towards positive and negative infinity, y tends towards 0. This means then that y equals 0 is going to be a non-vertical asymptote. And y equals 0 is just your x-axis. So what we now need to do is take all of these parts. So we will have it crossing the y-axis at 0 and then negative 1/6. So draw out your x and your y-axis. Put that point on as 0, negative 1/6, so we've got that point there. We know the graph does not cross the x-axis, perfect, we need to keep that in mind. We've got a vertical asymptote at negative 2 and 3, so if you draw them in, you've got your vertical asymptote, the vertical line at negative 2 and 3, normally just draw them as a dotted line, and non-vertical asymptote as y equals 0, in other words, your x-axis. You need to think about what the graph is going to be like, and what I'd maybe do is start with the vertical asymptotes, what happens either side of them. So when we had 2, what happens just before that? Well, you can see that the graph just before that was going towards positive infinity. So we know the graph was going towards positive infinity, so it was getting closer and closer to that asymptote, but not quite touching. On the other side of negative 2, with negative 1.9, we were down at negative infinity. So over here, we know the graph was going to be a negative value and it was going to be going down towards infinity. So we know the graph will be looking something like that. Take the other asymptote when we have 3. Think about what happens to the left and to the right. So to the left, when we had 2.9, it was going down towards negative infinity. So just before 3, you know the graph is coming down towards negative infinity, so it's going to be approaching that line but not quite touching. On the other side with 3.1, because we had a positive value here, it means it's coming from positive infinity, so it's going to be coming from up there, so it'll be looking something like that. And you can see for these parts that you've drawn in, you should have the line that's getting closer and closer and closer to the asymptote, but it's not going to touch. And imagine if you continued that up there, again it would get closer and closer and closer. It's the same down here. If you extend that down, well, this line will get closer and closer. It's the same here, and it's the same here. What you now do is you think about what happens to the rest of it. Well, taking this part on the left, we know that this x-axis is a non-vertical asymptote, so you know that the graph is going to be approaching that. This bit in between, we could probably guess, just join them together, and it would look something like that. And if you extend that, it's going to get closer and closer and closer to this axis, but it's not quite going to touch. So the graph will look something like that. For these bits here, we know the graph is coming up here. We also know it's going to be coming up from here. We know that it's crossing the y-axis at 0, negative 1/6. So from there, you know that it must be going through. However, once it goes through, it's not going to be going up. It's not going to be crossing over. We know that it has to be coming back down here. So there must be some point that it turns and then heads back down. If we were asked to work out the equation of a turning point, we may very well find there is a turning point there, but we weren't asked for that. And the last bit here, you know that the graph is coming down from positive infinity. Again, you know that this axis here is a non-vertical asymptote, so the graph will get closer and closer. So all you're doing is you're just joining them together and thinking, well, the graph's probably doing something like that. So that answer is what you would get if you graphed y equals 1 over x plus 2 bracket x take away 3. Example 2, sketch the graph of y equals x take away 3 over x squared plus x take away 2. And once again, you do not need to find the stationary points. So the first things to find for the graph, find out where it crosses the x-axis and find out where it crosses the y-axis. So it's going to cross the y-axis when x equals 0. Brilliant. So when x equals 0, you will have y equals, replace all the x's with 0, and you'll have negative 3 over negative 2. Two negatives make it positive, so you get 3 over 2. So you know the graph will cross the y-axis at Dun, 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 dun. 0, 3 over 2. It's going to cross the x-axis when? When's it going to be? Brilliant, you've got it. When y equals 0. So when y equals 0, you will have 0 equals all of this fraction. How do you solve that? Adam. Perfect. Multiply both sides by x squared plus x, take away 2. If you do that, you will end up with, well, if you multiply all of this by 0, it will stay a 0. So you'll just get x take away 3 equals 0. If x take away 3 equals 0, x will equal, good, x will equal 3, meaning then it is going to cross the x-axis at 3, 0. Once you have found out where it crosses the x and y axis, what do you then think about? Vertical asymptotes. Perfect, you think about them. When do they occur, Katrina? Good, vertical asymptotes occur when the denominator equals 0. So Katrina, doing that, you will end up with the denominator x squared plus x take away 2 equals 0. Go on, factorise it, what would you get? Good, well done. So you'd have x plus 2, x take away 1 equals 0, giving you two values of x equals negative 2 and x equals 1. So you know you have vertical asymptotes at negative 2 and 1. So you're going to have your vertical lines drawn in. The first one will be at negative 2 and the next one will be at 1. What you need to do once again though is you need to investigate the behaviour either side of the asymptotes, because once again you know the graph is going to approach positive or negative infinity. Is it going towards positive infinity or negative? Again, is it coming from positive infinity or coming from negative infinity? And the way you work that out is by considering a point just to the left and just to the right of the values. So if we had negative 2, take a number just smaller than that, so negative 2.1, and a number just larger, negative 1.9. All you do is you sub these into the original equation and find out if you get positive or a negative. That's all you're interested in. So if you sub in a negative 2.1, you end up with a negative value. Because you have a negative value, you know the graph's going to be going towards negative infinity. With negative 1.9, so just to the right of that, if you sub in negative 1.9 in here, what do you end up getting? Positive! Perfect. So because it's a positive number, you know it's coming from positive infinity. With 1, you're doing the same thing. You know it's going towards positive or negative. It's coming from positive or negative. So pick a value just less than 1, so 0.9. If you sub that in, you get a positive value. Good. Because you have a positive value, it means the graph is going towards positive infinity. And after that, is it coming from positive or negative? We'll sub in a value bigger than the asymptote. Again, just go out by 1 decimal place. So we've got 1.1, and that gives us a negative value. So you know it is coming from negative infinity, and it'll look something like that. So that is the vertical asymptotes. What do you look at next? Good. After that, you will look at the non-vertical asymptotes. What do you think about, Heather, when you have non-vertical asymptotes? What do you need to consider? Good. You need to consider what happens as x tends towards infinity. So we had y equals x take away 3 over x squared plus x take away 2. Does anybody know what would happen as x approaches positive or negative infinity? Perfect. Well done, Ian. You're perfectly right. Y would tend towards 0. And the reason for that is the degree of the numerator is less than that of the denominator. So if you put in a big number approaching infinity and then square it, well, the denominator is going to end up a lot bigger, which means you'd be dividing this by a bigger and bigger number. And when you divide a fraction by a bigger and bigger number, well, it is going to tend towards 0. So you can say that y equals 0 is going to be a non-vertical asymptote. If you get y tends towards 0, all you do is swap tends towards with equals, and that will be the equation of the non-vertical asymptote. Obviously for this, y equals 0 is your x-axis. Now all you want to do is take all of these parts. I've just summarised them at the top here. We know the graph crosses the y-axis at 0, 3 over 2. So just marking that on, 0, 3 over 2. Mark on as well where it crosses the x-axis at 3, 0. So there's 3, 0. I know we've got vertical asymptotes at negative 2 and 1. There's negative 2. There's 1. So just mark them on. Put on the vertical asymptotes just with a dotted line. And here. And we know there's a non-vertical asymptote as y equals 0, of y equals 0. So in other words, your x-axis. Again, I would probably start with, when I'm drawing it, the vertical asymptotes. So, taking -2, first of all, to the left of -2, what's happening? Well, I know the graph is going towards -infinity. So the graph for this one must be looking something like that. So it's going to get closer and closer to that line, but it's not going to touch. After that, look at what happens to the left or the right of that line. To the right of it, you've got -1.9, and to the right, therefore, it is positive, so you know it is coming from positive infinity. So that's a line again that the graph is going to get closer and closer to, but not going to touch, because you get a positive value, it's positive infinity, so it's coming from positive infinity. With 1, what happens when it's less than 1? Well, just less than 1 is going towards positive infinity, so you know the graph will be going towards that line. Again, it's not quite going to touch the way I've probably drawn that touching. You maybe want it looking something like that, which is still touching. Never mind, you get the idea. With 1.1 as well, with 1.1, so it's just bigger. Well, just bigger, it's going to be at negative infinity. And for negative infinity, it's going to be looking something that looks like that. After that, just piece together the rest of the graph. Well, we know this axis is also an asymptote. It's a non-vertical asymptote, which means as the values of x get bigger and bigger and bigger as they approach positive and negative infinity, then your graph is going to get closer and closer to it. So we know down here to the left, the graph is going to look something like that. It's going to get closer and closer, so we can easily piece that bit on. With here, once it's coming down, well, what happens next? Well, we know it's going to somehow cross over this y-axis, and that's where it crosses over. Where does it go after that? Well, we know it's not going to go down the way because it's going to approach positive infinity. So it'll be going up something like that. And to the right of 1, well, we know from here the graph does cross over your x-axis. So the graph can cross over asymptotes. The asymptotes just show what happens as really the x or the y approaches infinity. It's going to get closer as it approaches. So earlier on it can actually cross over. And we know from here it is going to cross over there. However, what's going to happen? Is it going to keep on going up? Well, no, it's not going to keep on going up because this axis is a non-vertical asymptote. And we know because of that, the graph has to get closer and closer to it, which means there must be some point that the graph will turn and then head back down. Again, if you're asked for stationary points, you will see that there must be a stationary point here somewhere. We're not asked for that, it's not really important, but there must have been one somewhere. And it's the same here, there will have been a turning point somewhere here. So that is the answer you'll get for that one. Try some of these on your own, sketching rational functions in the Unit 2 booklet, page 36. Check your answers as you go. Best of luck. Just make sure you follow all of these steps and remember the asymptotes. Best of luck. Have fun.